Hello everyone. So in today's class, let us discuss one very important concept and one of my favorite concepts of physics, which is called reduced mass system. So often students, so they'll be afraid to use this concept because they don't know like in what way, like how they can use this concept or how it is working. So they don't know the like the basics of this concept, or like they don't understand what is this reduced mass concept actually is. But believe me, after knowing this concept, so like till now you would have solved many questions in in a different way. So that's like basically, according to me, it's a lengthy way. So after knowing this concept, we'll be able to solve these questions like in what, like in a short manner, and it's like also a beautiful way. But it's not applicable for in all the cases. So we'll see in what cases it is applicable, like when it is applicable, the limitations of this, why it should be applied, how it should be applied, okay, where it should be applied. So all these things we are going to cover in this today's class. Okay, but as I said, so without knowing this concept also, literally each and every question you can solve. But knowing this concept will ensure that like the way that you will solve the questions will become very easy. Okay, so it won't take much time, and it won't take like much efforts in solving the questions if you know this concept. But you also need to ensure how to use it, when to use it, and where to use it. So these are the questions that we need to understand: how, when, and where. So all these things, so I'll try to clarify in this class. Okay, then, so let us try to jump into the concept. So the concept, today's concept is what? Reduced mass. So like by using this concept, so I'm just going to tell what are the chapters, or like what concepts you can deal from here. So the first one is spring block, you can deal. Okay, spring block systems. And next one is wedge and block questions, wedge and block problems. Okay, and the third one is friction. In friction, where friction with like again blocks, wedge and blocks, friction with blocks, or like wedges, whatever it is. And then gravitation, you can use this in gravitation, and I can use this in electrostatics. I can use this in electrostatics. Okay, also I can use this in atomic physics. And also I can use it in what? Nuclear physics. So basically, so this single concept, okay, single-handedly it can help us solving the standard models, or like very important questions based on all these topics. So that is spring block systems, wedge block systems, frictions, and one more important concept I forgot to write over here. So that's also very important. So the one more important concept which you can tackle using this concept is collisions. This is also very important. Okay, so these are the like different topics which you can easily tackle after knowing this concept. But as I said, not the complete chapter. Okay, so there'll be some models. Okay, like there'll be some models which you can tackle by using this concept of reduced mass. And literally see how many chapters there are. Like total eight chapters, or like eight different like eight different types of models you can just tackle by using a single concept. It will be helpful in solving literally eight types of eight different chapters, and eight different like models of questions that they can create, right? So okay, so by this you would have understood how important this topic is. But now, as I said, our question is when, where, and how, right? So first, let us try to understand what is this reduced mass system concept. Okay, reduced mass system concept. Okay, so we know Newton's laws are valid only in what? So let's discuss like points. Okay, so we know Newton's laws are valid on inertial frames, right? Only on what? on inertial frames. So then what will you do if non-inertial frame is there? Then Newton's laws are not applicable, right? Then Newton has come up with an idea and a solution that he told, okay, if we want to, okay, if we want to solve the questions from non-inertial frame, then what he has told? So he has told that you do one thing for me, you just add a false force which is called a pseudo force. Okay, you just add a false force which is called a pseudo force, then you can apply my laws. Okay, that's what he had told. So like the Newton's laws are failing when you are going to a non-inertial frame and applying those laws. Then he has come up with a solution that, okay, if you want to go onto a non-inertial frame, do me a favor, you just add a false force on top of that object which is called as pseudo force, and then you proceed to apply and you proceed to solve the things, then there is no issue. So that's what he has told, right? So if you want to solve the questions from non-inertial frame, use a pseudo force, right? So you might be thinking, so why I am telling you all these concepts now? See, like the pseudo force concept, why will you use this pseudo force concept? Why will you go to a different frame and do the analysis? We go on to a different frame. We should have solved from the ground frame, right? We should have solved from the ground frame. What is the reason for like us to go to a different frame and solve it? What might be the reason? Obviously, the analysis will become so easy by going on to that frame. As the analysis become very easy by going on to the frame, so that's why we are doing it, right? So we do it so because the analysis becomes easy and understandable. So you can easily understand like what is happening from ground frame. In some situations it will be very difficult for you to like see what is the scenario, what actually is happening. But from the like some accelerating frame, okay, going into that particular frame, then you would be able to judge what is happening or like visualize what scenario or what scene is happening there. So that is the reason we go into a frame to ensure that the analysis will become easy, right? And now also I'm going to do the same thing, okay? Now, but there you need to understand that by doing what, I'm ensuring that Newton's laws are valid. By changing basically the force, I'm adding a force, that means, or I can tell by changing the acceleration indirectly. When I add force, I'm changing the acceleration directly, right? That means by doing a small change, then I was able, like going on to a different frame, I was able to use what? Newton's laws. Similarly, now also I want to go on to a different frame, but this is a different way of approaching into the question. But now I don't want to add any pseudo force, or I don't want to do any of this stuff. There is another way of like tackling questions also, different way. So instead of using pseudo force or like pseudo force concept, so there is a different way of approaching the questions, that is called as what? Reduced mass. So that means earlier when you go on to like different frame to ensure that the analysis become easy, so you used to apply pseudo force, right? This is very much familiar for everyone. Okay, so I am not elaborating it, I am not telling all these cases, so that's it's clear for you, because in many chapter, like many of the cases in many of the books, you will find different models on based on this, and you would have tackled these questions, right? But you need to understand that those type of models and those questions can also be solved from the using different concept, by using different concept which is called as reduced mass concept. As I said, again in this case what will we do? No, when, let's say, first of all I'll tell you when this thing should be used, okay? When to use, keep these points in mind, sir. When to use this one? When to use means two block systems, two blocks, or I can say two particle system. You can use this reduced mass concept only for what? Two particle system, and also net force on the system should be zero, not on the individual particle. net force on the system should be 0. When these two are like valid, okay, when these two are valid, so if these two boxes are like tick for us, okay, if these two boxes are tick for us, then we can use the reduced mass concept. That means the first question is clear, when to use, this is the thing, okay. So then the third point, how to use. Then the third question comes, third question that arises is how to use, right? How to use. Sir, how to use? How to use means simply ensure that you just go on to top of like a block. Okay, I'll give an example. Let's say there is a question where there are two blocks. Okay, let's say imagine there are two blocks like this. 1 second. Two blocks like this connected by a spring. And let's say this got some mass m1 and this got some mass m2. Okay, now like let's say they're applying some force on top of these things, or they have given some velocity and all that stuff, and then you guys know both the things will be accelerated. Why? Because of the spring force. Okay, but net force on the system is 0, so that means acceleration of center of mass is 0 and the velocity of center of mass will remain constant. All that stuff is fine. But here you need to understand now I would like to solve the question by stopping one of the blocks. Why? Because we know, as I said, we'll use the pseudo force concept to ensure that the analysis becomes easy, right? So how the analysis become easy? When you go on to that frame, simply like you will be able to see only one object is moving, right? And similarly I want to do the same thing, but in the pseudo force questions you can see the acceleration would be constant. Mostly the acceleration would be constant, so then you can simply add a constant force of pseudo force MACM. But in this case, let's say because of some reason the blocks are moving with different velocities and the extension will be keep on changing. As the extension keep on changes, the acceleration of these blocks will be keep on changing. When the acceleration of this block is keep on changing, if you go on to any frame, it's a non-inertial frame obviously, and what pseudo force you will be adding? Do you know the value of pseudo force? Obviously you don't know. Why? Because the extension is keep on changing. When the extension is keep on changing, obviously the pseudo force will be changed, right? So then with what force you will represent and solve the answer? So it will be difficult for us to like approach this question by using pseudo force concept. But I want to make the situation easy. So how can you make the situation easy? I can make the situation easy by going on to a different frame. That means now I wanted to analyze this system by going on to top of this frame. Okay, so then what will happen? After going into top of this frame, this system will become equivalent to something like this. So how this system will become? Now when I go into the system, earlier we used to add the pseudo force, right? Earlier we used to add what? Pseudo force. Now we are not going to use pseudo force now. Okay, why? Because as I said, that approach is very difficult for us now, because I don't know the value of acceleration. It will be very difficult. Now once I climbed onto this, now this block will be a rigid block for me. This block will be a rigid block. It's stopped. Okay, it's not moving anywhere. Then sir, how it is possible? How can you tell it's not moving? So that's the concept of reduced mass over here. Then the other block is there, right? Other block mass should be changed. Okay, like Newton's second law is what? F net equal to ma. And you know that real force, like whatever the forces that are there, real force that are acting on body, that shouldn't be changed. Earlier, the Newton's second law you are correcting by the help of what? Changing the acceleration. That means indirectly applying the pseudo force. Now I am going to a different frame and I am ensuring that again the Newton's laws are valid, and that means I am going to get the same results by changing mass. That means you need to understand that like this Newton's laws can be corrected on going to a different frame, not only by the help of changing acceleration, by changing mass also we can ensure that what? Newton's laws are applicable on going into a what? On going into a different frame. So I hope it is clear for now, like how to use and why it should be used. Why? Because obviously on going to a different frame, I need to use what? I need to use pseudo force. I need to use what? Pseudo force. That is like when acceleration is known. But now acceleration is like completely varying, right? variable. So then it's very difficult for me to use the pseudo force concept. That's why now I am not correcting acceleration part. In F net equal to ma, what part I am trying to correct so that I'll get the same results of the original system? You need to ensure what? When I say equivalent means what? You know pretty much well. Equivalent you will be seeing in many chapters. The same result should be produced, right? The essence of the question shouldn't be changed. Simply, sir, it will be easy for me, so I'll stop that block and I'll analyze. It's not correct, right? So you need to ensure that you will be getting the same case, equivalent, same results you will be getting, right? To get the same result, now I'm not going to change the acceleration. I'm not going to add the pseudo force here. I'm going to a different thing. I'm going to do the correction in mass. That correction in mass is only called as what? Reduced mass. Whatever the correction that I'll be doing in reduced mass, that correction is only called as what, sir? So whatever the correction that I'll be doing in the mass, that is only called as reduced mass system, reduced mass concept. Now when this mass is fixed, this whatever the mass that will be there for other block, now it no longer be what? M2. So it will be a mu. Sir, what is that mu? So mu will be given as formula m1 m2 by m1 plus m2. Okay, so by doing this, sir, how we got this? So proof and all, it's not required. Okay, so if you want, I guess you might solve it by taking different cases, but here the important thing is equivalent means by taking this mass and this scenario, we are going to get the same results whatever our original system is giving. And this is only called as what, sir? This is only called as reduced mass. This is only called as what? Reduced mass. Okay, I hope this is pretty much clear for you. So here what we are going to do, here we are going to do the mass correction to ensure that the situation analysis become easy for us on going to top of another, like one frame, right? So this point is also very clear. So how to use this means, like when you're going to top of one frame, the mass of the other frame should be what? The mass of the other frame should be like changed. It won't be m2. Okay, it won't be, no longer it will be a mass m2. So you need to replace that block with a reduced mass, which is given as what? M1 m2 by m1 plus m2. Okay, so and before explaining this, before going into explaining all these different models, so I'm just going to tell one more important concept over here, that is when two block system are there. Already I told you this should be used only when two particles are there, when F net on the system is 0. These are very very important. Okay, like the same way how the concept is very important, just knowing the concept is not important, right? You also need to know when to use and where to use and how to use, right? So you can use only when these two things are like ticks for us. These two are valid, then only you can use this formula. Not formula, this concept. Okay, that's fine. So then here the third one, the kinetic energy of the system when two particle system is there. Remember, kinetic energy of the system can be written as half into total mass m total into VCM square plus half into reduced mass into V relative square. Okay, so this formula, if you want, you guys can derive it. Okay, it's not a big task, but I'm not going to do the derivation part because then the video will become very lengthy, and I want to discuss all these types of models here. Okay, and it's not a tough one. Okay, so believe me, I already solved it. So you guys can also take one case and you can derive this. Or like you can do like these type of derivations will be available. This derivation is not available in HC, I guess, but these type of things, derivations you would be seeing in center of mass. Okay, so like writing velocity of block. Okay, velocity of some block with respect to center of mass can be written as velocity of block in vector form. Taking vector form and writing the energy and doing the derivation, you will be easily getting this. Similar type of derivations you can see in HC, as I said. So half total mass into velocity of center of mass square plus half into what? Half mu into V relative square. Mu is the reduced mass and V relative is the relative speed. Okay, sir. So you understood this will be the kinetic energy of the system. Now, as I said, we can use these formulas only when net force is 0, right? We can use these formulas, these concepts only when net force is 0. So net force 0 implies what? Acceleration of center of mass is 0. Acceleration of center of mass 0 implies what? Velocity of center of mass will remain constant. velocity of center of mass remains what? Constant. That means you need to understand that this is always valid. This is always valid. This formula is always valid. But now we are in a special case. We are in a special case where net force acting on the system is zero. To use the reduced mass concept, net force acting on the system is what? Zero. And acceleration of center of mass will be zero. That means velocity of center of mass will be what? Constant. That means now considering this formula, you need to understand that whatever the thing that might be happening, okay, all these things, all these formulas where if we ensure that net force is zero, whatever might happen, this value is not going to change, right? This value will never change. Very, 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 very important. Okay, so you need to understand that. Copy. One second, let me copy this and then paste it. And color, change the color. Yeah, so here you need to understand that whatever this value is there, this value will remain constant. This must remain what? This must remain constant. This must remain constant. This is not going to change. So why? Because already I told net force acting on the system is zero. Acceleration of center of mass zero. Acceleration of center of mass zero means obviously velocity of center of mass should remain constant, irrespective of whatever the things that might be happening. Okay, sir. So that's fine. That's clear. That means this value should remain constant. That means whatever might happen for this system, only thing that can vary is this one. Okay, you need to understand that this is the part. This is the part which can vary. This is the part which can change. This is the part which can change. Okay, which part? The half mu into v relative part. This is the part which can be changed. So why you need to understand this formula, you'll understand in a while. Okay, so as I said, now this understanding about reduced mass is fine. Okay, now we'll try to get more and more clarity by taking up the questions from each concept here. First, let me take a spring block question. Okay, question number 1, model 1. As I said, I'm going to cover different models. Model 1. What are the different models that you can cover using reduced mass concept? Okay, I'm not going to give many examples. Okay, then the video will become very lengthy. So I'll just give like one example from each model, and you should be able to solve it. Okay, you should be able to analyze after watching this video, and the analysis part should be done on your own. Okay, the basics I'll be like providing you the basics, then the further analysis and further understanding of the concept must be done by you, right? So then only there will be development in the subject. So let's say there is m1 mass, and this is m1 mass, and this is connected to a block of what? m2 mass. Now they're asking, let's say this is given some v0 velocity. Now they're asking what is the maximum extension in the spring. Maximum extension in the spring. So I'll be doing it in two different ways. Okay, I will be doing it in two different ways. They're asking maximum extension in the spring. First of all, you need to understand in this case, net force acting on the system is what? Net force acting on the system is zero. Net force is zero. Yes, sir, net force is zero. When net force is zero, you know velocity of center of mass will remain what? Velocity of center of mass will remain constant. Yes, sir, this is also fine. We know this. Okay, so if you know this, fine. Let us proceed. Velocity of center of mass is constant. Good. So when velocity of center of mass is constant, this will remain constant. That means only energy that can vary is what? This one. And we know that there are no non-conservative forces here. No non-conservative forces. No non-conservative forces. When there are no non-conservative forces, which implies energy should be what? Energy should be conserved. Energy is what? Conserved. When energy is conserved, okay, that means total energy should be constant. When some amount of this kinetic energy of the system is lost, when some amount of kinetic energy of the system is lost, that energy would have been stayed with, like, converted into what? Spring potential energy. That energy would have been changed into what? Spring potential energy. But as I said, this is the value which can change. Okay, that means only how much value of the kinetic energy of the system can be converted into like spring potential energy, this much value. When will you get maximum extension? We get maximum extension, see, very very important, see, within one step it's done, right? So we get maximum extension when total energy that is variable, total energy that is variable, that means which can change, variable, with the total energy that is variable is converted into what? Is converted into spring potential energy, is converted into spring potential energy. That means what, sir? That means simple, done. The total variable energy is what? Half mu into V relative square. Now this entire thing should be converted into what? This entire thing should be converted into spring potential energy. So that means half K x max square. Half K x max square. So from here you are going to get the maximum extension in the spring. You are going to get the maximum extension in the spring. But the same thing I can also do it in an alternative method. I can do it in an alternative method. Sir, what is alternative method? The main essence of this topic is what? Reduced mass system, right? Reduced mass system means already I told you. Now what I'll be doing, you know? I'll jump onto this first block. I'll jump onto this first block. So what will happen when you jump onto the first block? Yeah, let us see. Ting, 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 ting. Jump. But now the mass over here, it won't be what? It won't be m2, it will be what? Mu now. And you need to understand that this is fixed. Now this cannot move. This m1 cannot move. This m1 is fixed. That means you need to understand that. Let me just draw a situation like this. Now this is fixed. This is not going to move. This is simply like a what? Spring block system. A single spring and a block system which only this block can move. Right? This system cannot move anywhere. And you might be having a doubt, sir, what if both are having velocities? When you stop this, you need to understand that we also need to give what? Relative velocity. We need to give what? Relative velocity. That means with respect to this, let's say for suppose this is also going left side with v1 velocity. Then when you stop this, velocity of this one should be what? v0 plus v1. Very very important. Okay, when you stand on top of this, you should also change the relative velocity, right? We are stopping we are standing on that one. Obviously, we need to change what? The velocity of this particle also. If this is moving, in this case it is not moving, that's why the velocity became what? V0. Otherwise, be careful, you should be changing the velocity as well. Now yes sir, it's converted into a single spring and single block. Now this block is not moving, no? So it's very simple system for simple system for us. One block is there, one spring is there, and it's given some velocity v. So when you are going to get maximum extension, when total kinetic energy is converted into what? Total energy, kinetic energy total. If kinetic energy total is converted into what? We are going to get maximum compression when kinetic energy total is converted into what? Potential energy total. Complete kinetic energy, if it converts into complete potential energy stored in the spring, then you are going to get x max. Sir, what is the kinetic energy for this block? Kinetic energy of a block formula is what? Half mv square. So half into mass of that block is what? Mu into v square is v0 square. And what is the kinetic potential energy stored in the spring? Half k x max square. Half k x max square. So you guys can clearly see that I got the same result by approaching in two different ways. As I said, let's say if velocity v1 is given here, then it will become what? v0 plus v1 whole square. Then still it will be half k x max square. Let's say v0 given in this direction, v1 given in this direction, then relative velocity will become what? Relative velocity will become half v0 minus v1. So as I said, so in this case the relative velocity has become v0, so that's why I got this formula. But this is for any general case, right? And the general case approved from here also, right? Basically when you stand on top of this one, you shouldn't write this as v0, you should be writing it as v relative. In this case that v relative is v0, that's why I got this answer. Don't think that, sir, here you told v relative and here you told v0. In this case v relative is nothing but v0, right? That's why I got this answer, right? So I hope it's pretty much clear, right? So like this you can solve multiple questions. What is the time period? Time period also now I can easily find. It's a one spring block. It's simply as one spring block system, right? Time period is nothing but what? Simply 2 pi root m is not here mu, so 2 pi root mu by k equivalent. When multiple springs are there, then you can also write simply 2 pi root mu by k equivalent. So this way you can find time period, you can find frequency, you can find energy, you can find extension, whatever you want you guys can find, simply by ensuring that you, like, indirectly we are doing what, on going to top of one block, on going to the top of one block and stopping it, indirectly we are converting this two block system to what, indirectly we are converting indirectly we convert this two block system to what, two block system to one block system. Then the analysis will become easy, right? Indirectly we are converting this two block system to a what, single block system, right? Okay sir, understood this model 1. Now let us go to a model 2, wedge block system, right? Model 2. So I guess if I discuss all the models it might become very lengthy, so anyway we'll see. So that's why I'll try not to solve till the end. I'll just give the concepts for you, from there you can approach. Okay. Model 2 is blocks like wedge and block system, this stuff, right? So this question you would have seen for sure, this type of question. Let's say there's a wedge like this, and they'll tell that mass of this is capital M, and then on top of this there will be a block, both are free to move, block small m. Now they'll be asking what is the minimum velocity, that should be given, so that it will be raising to a height h. This will be the question that they'll be asking. What's the minimum velocity that should be given? Okay, minimum velocity that should be given so that it will be raising, it will just raise. Okay, it just raises to the height what? H. So how to solve this type of question? Again, you can see that net force acting on the system is what? Net force acting on the system is 0. So that means velocity of center of mass should be conserved. Again, the same story. F net. Okay, in what direction? Horizontal direction I am speaking. Okay, obviously in vertical direction there will be a weight and normal force due to what? Ground. But in those two will also get cancelled, right? So even if you consider those two, anyway net force on the system will be 0. Net force on the system is 0. Okay, net force on the system is 0. No. When you take free body diagram of this one, you should only be taking, one second, anyway it's not moving, right? This normal will get cancelled. Fine. And this n and g, it's not going to move, so here this one also will be 0. Fine. So net force is 0. Means acceleration of center of mass 0. That means velocity of center of mass should remain what? Velocity of center of mass should remain constant. Okay, so when velocity of center of mass should remain constant, that means only energy that it can only energy that can be changed is nothing but what? So I will be using energy conservation. So first let us keep this in mind. So now I will use the energy conservation, that is initial total energy initial will be equal to total energy final. Total energy initial equal to total energy final. Sir, what is initial and total energy? Half m u minimum square. Okay, half m u minimum square. Actually, let us take it as u square and make it minimum later in the next step. Half m, let's say u speed is there, half m u square. Plus initially it is at ground level, so potential energy will be considered as what? 0. And for the next case, I need to write the value of what? I need to write the value of energy for this system. Okay, instead of writing like this, let me do one thing. 1 second. Initial total kinetic energy I will be writing this way. Half into total mass of the system is what? M plus m into VCM square. What is the VCM? Okay, that I am not bothered about. If you want, you can find, right? So VCM is nothing but what? M1 V1 plus M2 V2 by M1 plus M2. So anyway, I am not bothered about that value. Plus half into mu, reduced mass into what? Reduced mass into V relative square, reduced mass into V relative square, plus, as I said, initial potential energy will be what? 0. This is our initial energy. And what about final energy? Finally, as I said, still it is going to have the same center of mass. Center of mass velocity of the velocity of center of mass will remain same. So this will be the kinetic energy of the center of mass, plus let's say after going to a height h, it will be having some different relative velocity. I am calling it as V relative dash. V relative dash. V relative is the initial relative velocity, and this V relative is the what? Final relative velocity. Plus now it has climbed some height also, right? It has climbed some height also. So as it has climbed some height, so I'll be equating it to what? I'll be equating it to mgh, small mgh. Sir, what is this V relative? This V relative is initial relative velocity. Initial relative velocity, fine. And sir, what about this V relative dash? Final relative velocity. Final relative velocity, fine. So that means in this question, this one and this one will get cancelled. Now if you want u minimum, okay, if you want u minimum, obviously I'll take right side. I want to take the what? Minimum value. What is the minimum value for any square? So what is the V relative initially? Initially V relative is nothing but this doesn't have any velocity. So therefore, what is the value here? The value here would be, initially the relative velocity is simply half m reduced mass. I need to write, no? Reduced mass. So small m capital M by small m plus capital M into what? Into u square, which is equal to half mu V relative dash whole square plus mgh. Okay, here the important key point comes. So what is the important key point? For the u to be minimum, I want the minimum value of the speed, right, for this height to be reached. So to make it minimum, obviously this value is constant, right? Only variable that is left out is what? The final relative velocity. So to make it minimum, right side should be made minimum, right? What is the minimum value of any square value? Right side, minimum of any square value is what? 0. For u to be minimum, V relative dash must be equal to what? 0. Very, very, very important point. That's what we'll be doing in normal method, right? Normally, if you remember, you will be doing the same method using momentum conservation and doing all that stuff, right? That means relative to this, we'll ensure that this will be at rest. So it will be little lengthy. Okay, so to make you understand, I am doing all this stuff, but otherwise after understanding this directly, the final step I would have wrote directly. So therefore, when this is 0, simply half reduced mass. Okay, I am keeping it as mu as well, mu only. So because mu already it's nothing but m by capital M small m by capital M plus small m, half m u. Now I won't write u, it will be u minimum because I have kept this value as what? 0. So it no longer will be u, it will be u minimum square, which is equal to what? mgh. See, within one step I would have written this formula if I know the concept of reduced mass. Or how, already I told you very important concept, that this, when net force acting on the system is 0, this energy cannot change, right? This energy cannot change. That means only energy that it can be spent. What energy it can spend? That means what energy it can consume or give it to the other sources. Only this energy, this cannot be lost. That means this is the only energy which can be given to some other thing. In the previous case, this energy is given to what? Spring potential energy. In this case, the same energy which it can give the maximum energy, it is given to what? Gravitation potential energy. That's it. That is the only difference. Okay, so here I have just done the proof, but otherwise in the exam, after understanding this concept, I would directly write this step. Okay, without any hesitation, because I know the maximum energy half m VCM square, half capital M. So here it's not capital M, okay, m plus m. Capital M is in the total mass. Half total mass into VCM square will remain constant. The remaining energy is the one which can vary and which can be spent in converting into different forms. There is spring potential energy. Later we'll see electrostatic potential energy, basically interaction energy between two charges, or like and then different things. Okay, in gravitation, okay, and like energy between interaction energy between two masses, all this stuff. As I said, simply here whatever the energy that we can consume is this much energy. That much energy will only be consumed, converted into what, that form, whatever the form that is there. In the previous question it is spring potential energy, in this case it is what, gravitation potential energy. So within one step we got the answer. Okay, without having, like, without doing any big, like, much analysis and all that stuff. And also from here you can tell this is possible only when v relative is what, final v relative is 0. That means we can also tell finally both must have what, same velocities. This wedge can only have velocity in right side direction. That means this block should also have velocity in what, right side direction. Okay, so and you can conserve momentum only in horizontal direction. You cannot conserve momentum in vertical direction, because on this thing there is an external force of what, on this system there will be an external force of normal force and mg. So that's why, as there is an external force, we cannot conserve. Okay, earlier as did I say net force is 0? No, net force is not 0, because this particle is moving, right? So as there is a net force in vertical direction, we cannot conserve momentum in vertical direction, but horizontal direction, as the net force is 0, you guys can conserve what? We can conserve the momentum in horizontal direction. That's what we'll be doing, and we can also find the final common velocity that both will get. So for which the relative velocity will become what? 0. So I hope this is also pretty much clear for you. Directly I would be able to write this value here. This is model 2. Okay sir, model 2 also I understood. Then model 3. Let us see model 3. Model number 3. So what is model number 3? Model number 3 is like this. This is also pretty much standard one. Okay, and this can be changed into like many like concepts. Okay, this can be changed, like put it in different ways, but as I said, I'm only here to make you understand how the things are working and how the questions are creating based on the reduced mass. So let's say this is capital M block, and this is, let's say, small m block, and let's say here it is smooth, for the ground it is smooth, and here let's say there is a coefficient of friction mu between them. So now, okay, this mu is not reduced mass. Okay, this is the coefficient of friction. Now the question is they'll be asking what is the work done by the system. When this is given some velocity v. Let's say this is given a velocity v naught right side. So obviously the frictional force on the top block will be in what direction? Left side. And on the friction on the bigger block will be what? Right side. So again in this question also, if you understand, net force acting on the system is what? Again in this question also, net force acting on the system will be what? 0. Net force 0 means acceleration of center of mass 0, which means velocity of center of mass should remains what? Constant. Yes sir, velocity of center of mass should remains constant. Velocity of center of mass should remains what? Constant. That means the part half m plus m into vcm square, whatever that is there, it should remain constant. So what is the only that energy that can vary? That variable amount of energy is what? Half into reduced mass. M reduced mass into what? Half into m reduced mass into v relative square. That is the only energy that can be lost, right? So you know that they're asking what is the work done by the friction, right? What they're asking, work done by the friction. So to find work done by the friction is going to do work. Friction is going to do work when is going to do work till relative motion exists. Relative motion exists. Okay sir, that means, so when the friction work done by the friction will be stopped after the relative motion is stopped. Okay, that is, friction is going to do work till the relative motion is stopped. That means when the relative that is finally relative velocity will become what? 0. Finally, very very important, this also will be solved within one step. Finally, relative velocity equal to what? 0. If relative velocity is equal to 0, whatever the second part is there, that is gone. What is the second part? Half into reduced mass, half into mu, like mu, which is capital M small m by m plus m, into V relative square. Now V relative is 0, that means that energy is completely gone. So in the total energy, what is the total energy formula, sir? If you remember, kinetic energy total is nothing but what? Half into m total into VCM square plus half into m reduced mass into what? V relative square. Now this energy is completely lost, right? The first part remains constant. This is constant. First part is what? First part is constant. And second part is what? Second part is completely lost. Completely lost. Sir, how I am telling completely lost? Because the friction will stop doing work when the relative motion becomes 0. When it is completely lost, this would have, like, who has consumed that? Who has consumed that? So the friction would have consumed that. So therefore answer is done. He would have consumed this? Friction would be consuming the energy. Friction would be consuming the energy which is lost. Therefore work done by the friction is nothing but what? Simply work done by friction is nothing but half into reduced mass. What is reduced mass? Half capital M small m by capital M plus small m into V relative square is what? V naught square. So this will be the answer. This will be the answer. Understood? So you can see that this can also be solved within one step if you know this concept. Okay, just within one step it can be solved. If you don't know this, then it will be like what? It will become lengthy and you need to do momentum conservation and then find the final velocity, then do initial energy minus final energy, then you are going to get this value only finally. After doing that much like long process, again you are going to land up to the same thing, which I am just telling it in a single step. Okay, with the concepts and the basics that I told. Okay, sir, I understood the model 3 also. Model 4. Model 4. Sir, what is the model 4 that I have told? Model 4 would be collisions, right? So in collisions, I'm not giving you like many questions here. I'll just tell the what concept it will be used here. I'll just tell you what concept will be used here and how to use it, and this questions part I'm just leaving it to you. So in the collisions, when our collisions are required, so the fourth model is what? Fourth model is collisions, right? Fourth model is collisions. So when our collisions will happen, you guys know these following points, right? What are the following points? Net force on the system will be equal to what? 0. Net force on the system will be 0. So net force on the system is 0 means velocity, acceleration of center of mass is what? Acceleration of center of mass will be 0. Acceleration of center of mass is what? 0. Which implies velocity of center of mass will remains what? Velocity of center of mass will remains constant. Velocity of center of mass will remains constant. When velocity of center of mass remains constant, no, that means again the same thing, same point will be used here. As I said, all the concepts are similar. All the concepts are similar. So again, as the center of mass, center of mass velocity should remain constant. So this first part should remain constant. That means only thing that can be changed is what? Only thing that can be changed is this value. Okay. So this is the value which can. The first one will remain constant. This is the one which can vary. This is the one which can change. So therefore, so let's say in collisions, we know that we have different types of collisions, right? Elastic, inelastic, okay, perfectly inelastic, all these things. So basically in those in all those cases, net force acting on the system is 0, so momentum should be conserved and the velocity of center of mass should remain what? Constant. So whatever the energy that will be lost in the system, or the energy that will be lost because of collision can be given within like one step. That is energy lost in the system. Energy lost in the system is simply given as what? E lost. E lost can be simply given as half mu into v relative square into 1 minus mu square. 1 minus mu square or 1 minus mu. I didn't remember the formula actually. Okay, you guys can derive it. Okay, the formula something, it will be like this. So why? Because when mu is 1, like obviously it will be an elastic collision, no loss of energy will be there. 1 minus 1, it will be 0. I didn't remember whether it is 1 minus mu or 1 minus mu square. That you guys can like derive it and check. And if it is perfectly inelastic, then mu value will become 0. When mu value is 0, then obviously total energy will be like what? Total energy will be lost. Total energy means whatever the variable the energy that can vary, that energy, total energy will be lost, right? If it is mu value is neither 1 neither 0, then some amount of energy will be lost. Okay, as I said, okay, I'm just highlighting this value. I didn't remember, that you guys can like derive it and check, okay, verify it whether it will be mu or mu square. But I want you to understand the concept here, okay? And it makes sense for you as well when it's perfectly elastic. Mu, my bad, why mu? What is mu here? E, no, coefficient of restitution. Oh my god. Coefficient of restitution E square. Okay, yeah, fine. So coefficient of restitution E square. Yeah, so this E value is what? 1 for perfectly elastic. If you take 1 here, 1 minus 1, 0, that means no loss of energy will be there. When it is perfectly inelastic, then E value would be what? 0. E value is 0, then maximum amount of energy will be lost, which is nothing but what? Half mu into V relative square, which you already know, right? So this is one more important concept which will be very much helpful for you in solving the questions from what? Collision chapter. Okay, so here also some of the concepts can be easily solved by knowing this formula. So this is the model 4. Okay, this is the model 4. Okay sir, model 4 also we have understood. Then model 5. Model 5, what chapter I have told? See, these two together I am explaining. Okay, gravitational force and electrostatic force together. Model number 5. Anyway, I can do it in two different models, but as both are like similar, I am keeping model 5, which is like what? Model 5. Model 5 is like both for like what? Electrostatics. Only when two charges are there. Okay, electrostatics and gravitation together. So in this, okay, so in my like previous class of one of the classes from Pathfinder electrostatic question, Pathfinder electric potential questions, I told I'll be solving a question, right? Like the question based on closest approach. Okay, what will be the closest approach in this model? In this model, basically I have fixed one of the masses. Okay, basically you will be doing it in two different ways. Okay, let's say this is a sun. This is sun, or like some kind of earth, and let's say this is meteor. Let's say initially coming with some v0 velocity, they'll be asking what is the closest approach. Okay, what is the closest approach? By fixing this, already I have made a video on this. If you want, you can just go and check in the playlist. So it's in electric potential Pathfinder questions I have done it. But in this question, when one is fixed, then we have done it by using like basics. Okay, now but let's say when both are moving, let it might be a gravitation or it might be electrostatic, doesn't matter. Okay, in gravitation the things works like with the thing of what? Gravitation, law of attraction force. And electrostatic will be like working because of what? This attraction or repulsion, that will be working because of the Coulomb force. And we know both the things are like similar, just the constants values will be changed, but the relation with the distance or separation between them will remain what? Same. That is inversely proportional to what? R square. So here I am just going to do that model. So what is that model? You know, when both the charges are free to move. When both are free to move. In the question that I explained, one of the things is fixed, or in gravitation that you will be seeing mostly one of the planet will be fixed, that is like sun or like earth or whatever it is. They'll tell a meteor is there, it's coming, and they'll be asking what is the closest approach. Okay, in that question, so it will be like different for you. It will like in that question it's very pretty much simple, for because already one is fixed. But here now I am creating a scenario where both can change, both can move. Okay, both can move. Let's say something like this. Both can move. Let's say this is q2 and m2. Now see how I'll be solving this question. In this question they'll be asking, let's say initially the separation between them is like infinite, and they'll tell the distance between the line of motion of these two things is what, d. Now they might be repelled like this. Okay sir, what will be the path of this one? This will be repelled something like this, right? And this will be repelled something like this, obviously. So the path would be very difficult for us, as both are moving, both the charges will move, both are moving. When both are moving, it will be very difficult for us to analyze, right? When both are moving, it will be very difficult for us to analyze. Now what I will be doing, I'll simply go and stand on top of one more charge, stand on top of another charge. When I go and stand on top of another charge, let us see how the system will be changed. Copy and paste. Let us see how the system is going to be changed when I go and stand on top of one particle. See, when I go and stand on one particle like this, so how, like this, then this particle will be fixed. Then this particle cannot move. Then this particle cannot move. This particle cannot move. But now, like, what about the charge? Charge, it won't change. Only reduced mass concept, right? Only mass will be changed. So what will be the mass of this one? It won't be m1 any longer. It will be what? Mu. So what is the mu? Already reduced mass concept is what? Nothing but mu. Already mu is nothing but m1 m2 by m1 plus m2. m1 m2 by m1 plus m2. Okay sir, then after this it's like again the standard question which I explained, right? The standard question which I explained. Initially it will try to approach, and then there will be a distance where there won't be neither velocity of approach will be there, velocity of separation will be there. Then after that again velocity of separation will be there. So therefore the transition, wherever the transition takes place, that is the r minimum, right? So from here, so you just know. Okay, so the complete video, very detailed manner I explain that question, you can go and check over there. So I'll be conserving angular momentum. Two things I'll be doing, right? Conserve angular momentum and energy with respect to the what? With respect to q2 charge. I just went onto this frame, okay, and this will become very easy for us. It will be converted into the standard case, whatever that is, has been already discussed, and which in most of the books already in Cengage it will be there. Okay, so you guys can go and check the closest approach when one charge is fixed. When but both are moving, then also you can apply this concept. So I hope it's pretty much clear. So I am not solving it. Okay, if I solve, as I said, the video will become very lengthy. Okay, so I told you the concept, what you can do. So I convert this into a single mass system that is moving, the other mass is what? Fixed. Then it's completely converted into the question which I already very detailedly discussed. You can go back and check to the playlist of electric potential pathfinder questions. Fine. Okay, so then the next model would be in atomic physics. Okay, in atomic physics, I guess in some AITS question paper I have seen there is a beautiful question where in general we know atom is fixed. Okay, atom is fixed, and around that electron will be revolving. And actually speaking, if this atom size is very very big, actually atom inside the nucleus, my bad, around the nucleus the electrons will be revolving. Consider to the electron. Okay, compared to the electron, the nucleus size is what? Nucleus size is very very big. So that's why, so we won't be taking any effect of electron on top of this one. But actually speaking, when this is applying force on the electron should also apply force on this one, right? So there is a very beautiful question, one of the Fiji AITS, or I didn't remember, but very beautiful question. So there they have given that the mass of the central particle of the nucleus is also similar to what? The charge which is rotating. The charge which is rotating, that means it is comparable. When it is comparable, then you cannot neglect the force due to that rotating particle on this one. In that concept also you need to use in that question also you need to use reduced mass. So if possible, I'll be bringing that question in some different series, maybe in AATS series. There you guys can go and check. But again, I said that concept also, again the core concept and key concept that should be used is what? Again the reduced mass concept, right? And the final model I just want to take up is the model number 6. The final model, model number 6. Model number 6. That is nuclear physics. Nuclear physics. Okay, so let us see how the questions, like I guess in 20 something, 2014 or like 2012, I didn't remember. So almost during that time, during that period, they have given one question based on this. The question is something like this. Let's say I didn't remember the what are the atoms that are involving, okay, what nucleus are involving in that process, but simply I'm just creating the question. Let's say a plus b equal to, let's say, some m plus n. There are two elements which are like added, okay, and to get what? M plus n. And obviously, let's say, okay, let's say I'm telling that this requires, so you know, like how to find q of the reaction, right? So let's say q is nothing but what? So m final, okay, q is nothing but delta m into c square, right? What is the q value here? Q value, you know, it's nothing but what? Delta m into c square. So let's say we know if initial in reactance mass is more than reactance mass is more than products, that means energy will be what? Released. Energy will be released. But let's say if products mass is more, okay, if mass of products is greater than mass of reactants, that is, we must supply what? We must supply energy to the system. We must supply energy to what? Energy to the system. We must supply energy to the system. And how they are asking us to supply energy to the system? They are telling that this particle is there, no? This particle is at rest, B is at rest, and for this they are telling they are giving some V0 velocity. But they are asking what is the minimum velocity that should be given so that this reaction can take place. If both are at rest, okay, as reactants mass is more than like what? Products mass is more than reactants, as mass of products is more than reactants, like the reaction cannot be done, okay, unless and until we are supplying what? We must supply some energy to the what? System. In what form we are supplying the energy to the system? We know when mass of reactants is more than mass of products, the energy will be lost, okay, the energy, how much amount of heat, like energy will be lost? Delta m into c square, and we'll say this much amount of q value, the energy is stored as what? Kinetic energy of the particles. Similarly, as here the mass of products is more and mass of reactants is less, that means we need to supply some amount of energy in the form of what? Kinetic energy only. Okay, now the question here that they are asking is what amount of minimum value that should be given so that this reaction is possible. That means now a plus b should be converted into what? M plus n. Then you might be thinking that, sir, simply I'll equate this q value to this one. No, again you cannot equate this q value. You might be thinking, sir, we need this much amount of energy, so we need this much amount of energy, so simply I'll equate half mv square to this much energy. No. Why? Because whatever the kinetic energy that I'll give it to a one particle, we know that energy cannot be lost completely, right? That energy cannot be lost completely. Why? Because already I told you, as the net force on the system is zero, acceleration of center of mass is zero, so velocity of center of mass should remain constant. Earlier whatever the velocity of center of mass is there, the same velocity should be what? Remain over here, right? That means you need to understand that whatever the energy that I have given, the total energy won't be what? The total energy won't be consumed. That means only some part of the energy will be consumed. So whatever the energy that is consumed, that should be used as Q, not the total kinetic energy which I have given to the particle. Okay, so I hope it is pretty much clear now. So that means in general here the equation that I should be writing is, so earlier I have told very clearly this concept I have told, right? So again you can use this, I can use this concept over here. So what's the concept? The concept is total energy initial will be equal to what? Total energy final. Okay, sir, what is total energy initial? Total energy initial is half into, let's say mass of that one is m1 plus m2 into vcm square plus half into mu relative. half into not mu relative, half into mu reduced mass into v relative square, v relative square, which is equal to okay, which is equal to this thing is equal to 8 plus some q also, right? Because sorry, my bad, mass of production is more. Yeah, so we need to supply some amount of energy to this one. So that energy we are supplying in what form? That energy we are supplying in kinetic energy form. So as a result, this will be equal to, finally product's mass is more than reactance mass, right? So as the product mass is more than reactance, the product side energy will be more. How much more? The q value more, q plus q plus half into m3 plus m4 into c square. Let me write the equal term right over here. So this value is equal to what? So this value is equal to q plus half into m3 plus m4 into what? M3 plus m4 into my bad. Simply half into total mass is not constant, right? Okay, let me write like this: half into m3 plus m4 into vcm square, as the net the mass is changing, right? Total system q value anyway it's there, okay. Then half into mu relative into half into, let me write this step, half into, let me write first the relative part, half into mu into v relative square plus v relative dash square, not v relative square, v relative dash, different relative velocity will be there, plus half into new mass m1 plus m3 plus m4 into vcm square, m3 plus m4 into what? vcm square. But velocity of center of mass will remain same. Why? Because net force acting on the system is what? 0. Now I want this value to be minimum, right? I want this value to be minimum. So how this value can be minimum? So this value can be minimum if this value is 0. If this value is 0, right? Some of these two should be equal to a constant thing, right? This should be a constant value. So this v relative square is nothing but what? V relative in this question is nothing but v. V relative in this question is what? V. So therefore, for it to be v minimum, for the v to be minimum, v relative dash must be equal to what? V relative dash must be equal to 0. Then only it will be minimum. So then from here you can keep this value as 0. Then you know the q value. Then you will be knowing this value, and you will be knowing this value. And from there, here what you can find? You can find the value of minimum velocity. Okay, you can find the value of minimum velocity. So I hope all these concepts are pretty much clear for you. So like literally, okay, by the help of reduced mass system, so we have approached, or we have tackled questions from 8 different chapters. Okay, we have tackled questions from 8 different chapters. Like basically through all these models that I've covered, so by this time you would have got a clarity that it's obviously a very very important concept. Okay, by like through which you can tackle literally like questions from 8 different chapters, which is like most very very important thing. So why it's not much stressed in the book, so why it's not seen means, obviously having like not having clarity or not having much understanding about this concept, that is one thing. And the second thing is each and every question can be solved without knowing this concept as well. So that's why it's not being emphasized in the different books. You will see the formula of half mu into v relative square, but you might not have seen that this can be used, this formula can be used, or this concept can be used literally in all these chapters. Okay, all the 8 chapters whatever I have given, all the different models. So I have given, you can see that literally by using this concept you can easily tackle all these questions, right? So Yeah, so this is how beautiful this concept is, and literally most of the like mini questions from mechanics, gravitation, electrostatics, like whenever I see that only two particles are there, net force on the system is zero, immediately I'll jump into this concept and literally I'll solve the questions in no time. Okay, instead of like solving the questions, compared to the students who will solve the questions from the ground frame or like normal standard methods, it will be very difficult and it will be lengthy. So obviously the question solving and the analysis and understanding will become so easy after going into this reduced mass concept. Okay, so I hope it makes sense now, when should be used, how to use, like how different models are can be created on top of this one. So literally I would have discussed many models already. It's like 1 hour 10 minutes, so I don't want to like extend the video here. But like after understand, if you go through this entire video, now you'll get an at least a bit of understanding what is like reduced mass. Then at least you will be realize something. Okay, it's an important concept, and this is how we should be approached, and you try to utilize this or use this in the questions. Okay, when like whatever the questions that I already told, you try to redo all those questions, and next time onwards, whenever you get a question like where net force on the system is zero, okay, both the blocks can have velocities in different direction, net force is zero, and only two particles are there, ensure that you use the reduced mass system and check whether you're getting the answer or not. You must get the answer. If you're not getting the answer, that means your concepts are not clear. Again, you just need to re-verify and check where it's going wrong, and obviously you're going to get the answer. And this is one of the best ways and like important ways of tackling questions where two particle system net force is zero. Yeah, so I hope it's pretty much clear for you. Okay guys, thank you, bye bye, enjoy.